Okay, proving lines parallel. Essentially, this is going to be the using what we've learned about parallel lines and their angles, and we're going to say, okay, well, if we know certain things about angles, then we can tell certain things about the lines that form them. So just to get back to some of the logic stuff we covered last chapter, the converse of a theorem is found by switching around the hypothesis and conclusion. And so we're going to use the converses of all of our parallel line theorems to show that the lines are parallel. So if I have, corresponding angles, alternate interior angles, alternate exterior angles, if the angles are congruent, then the lines are parallel. Same side interior angles, if the angles are supplementary, then the lines are parallel. Okay? So for example, I've got this quadrilateral here, and so I want to find out what values of x and y would make the red and blue lines parallel. Okay, so let's look at, now I could do the red lines first, but the problem is I've got x on one and y on the other, and that's really kind of too hard to work with right now. So I'm going to focus first on the blue lines. So if the blue lines are going to be parallel, then same side interior angles must be supplementary. Okay, so they're going to have to add up to 180. So I set up an equation. So x minus 40 plus x plus 40 equals 180. And then I combine my like terms. And so my minus 40 and plus 40 are going to cancel out. And so I'm left with 2x is equal to 180, which means x is going to be 90. Okay. Now, looking at it now that I know what x is, now I can plug that in and figure out what the same side interior angles are for the red lines. So replacing the x with 90, I get 90 minus 40 plus y equals 180. Well, that gives me 50 plus y equals 180, or y is going to be 130. Okay. Here's a more kind of formal type of proof. So I'm given that line segment BE bisects angle DBA, and I'm given that angle 3 is congruent to angle 1. And I want to prove that line segment CD is parallel to line segment BE. Well, here's how kind of the proof is going to work. Because I have an angle bisector, I know that angle 2 and angle 3 are congruent. And because I'm given that angle 3 is congruent to angle 1, then using substitution, I can sort of set everything all equal to each other. And I end up with angle 2 and angle 1 being congruent. Now, if you look at, where is my point? There it is. If you look at, this line here, these are the two lines that I'm trying to prove parallel. 1 and 2 are alternate interior angles. And so once I prove that those two are congruent, then that proves that these two lines are parallel. So that's kind of the idea that we're going to work with here. Okay, so set up with our given statement, we know that BE bisects angle DBA, and that's given. Angle 2 is congruent to angle 3. That's my definition of angle bisector. Now, from my given statement, I didn't use both of these. I could, but I wanted to kind of set it up a little bit better for the flow. So angle 3 is congruent to angle 1, which means that angle 2 is congruent to angle 1. And that's actually, that should be transitive property. Sorry about that. Because you've got 2 congruent to 3, 3 congruent to 1, so 2 is congruent to 1. But substitution can also work. And so line segment CD is parallel to line segment BE. And that's the way that I state that. Now, I'm not that picky on some of these, but if you're when you're doing the parallel line proofs, you need to be aware that you're using the converse of the alternate interior angles theorem. So that's kind of that word there. You kind of make sure you need to add if it's appropriate. Alrighty.